Look up this weekend. Seriously, you might get the chance to see one of the most beautiful and magical sights our planet has to offer. I'm talking about the Aurora Borealis, or the Northern Lights. Scientists have issued an alert for a solar storm that is heading our way, and it could trigger a spectacular light show in the night sky. Imagine vibrant curtains of green, pink, and purple light dancing above you. This isn't something out of a science fiction movie. It's a real phenomenon, a gift from our very own star, the sun. This weekend, that gift might be delivered right to your backyard, even if you live much farther south than usual. So get ready, because you won't want to miss this incredible celestial event. This weekend, specifically starting late Friday, August 8th, 2025, and continuing through Saturday, our planet is going to get a little nudge from the sun. A powerful burst of energy and particles, what we call a solar storm, is making its way across the 93 million miles of space between us and our star. When these particles arrive, they interact with Earth's protective magnetic field in a truly spectacular way. This interaction is what creates the dazzling aurora. It's a gentle reminder that we are part of a much larger, dynamic solar system, where events happening on the sun can have beautiful and awe-inspiring effects right here on Earth. Okay, so what exactly is this solar storm or geomagnetic storm we're talking about? Let's break it down. Think of the sun not just as a bright light in the sky, but as a giant bubbling ball of hot gas that is incredibly active. It's constantly sending out a stream of charged particles into space, which we call the solar wind. This solar wind flows past Earth all the time. Our planet has a secret superpower to protect us from this constant stream, a magnetic field. This field, called the magnetosphere, acts like an invisible shield, deflecting most of these particles away from us. It's our planet's personal force field, protecting life on the surface. But sometimes the sun does more than just send out its usual solar wind. It can have massive eruptions on its surface, almost like a solar volcano. Two types of these eruptions are especially important for us: solar flares and coronal mass ejections, or CMEs for short. A solar flare is an intense burst of radiation, like a giant flash of light. A CME, on the other hand, is even bigger. It's a huge explosion of plasma and magnetic field from the sun's outer atmosphere, the corona. Imagine the sun burping out a massive cloud of particles that travels through space. This weekend's event is thanks to a CME that is aimed right at us. When this big cloud of solar particles from a CME finally reaches Earth, it slams into our magnetic shield. This collision can cause our magnetosphere to wobble, stretch, and shake. This disturbance of Earth's magnetic field is what we call a geomagnetic storm. It's like throwing a rock into a calm pond. The impact creates ripples that spread outwards. In this case, the rock is the CME, the pond is our magnetic field, and the ripples are the geomagnetic storm. The strength of these storms is measured on a scale from G1, minor, to G5, extreme. The storm predicted for this weekend is expected to be in the G3, strong, to G4, severe range, which is quite significant. This is why scientists are so excited and why the aurora might be visible so far south. A stronger storm means a bigger disturbance to our magnetic field, which in turn means more energy gets channeled towards the poles. This extra energy is the key ingredient for the supercharged, widespread auroras we are hoping to see. So we have a geomagnetic storm happening. But how does that create those beautiful, colorful lights in the sky? It's all about energy and atoms. When the CME particles slam into our magnetosphere, some of them get trapped and funneled down along the magnetic field lines towards the north and south poles. Think of it like a giant cosmic waterslide, where the charged particles are the riders, and Earth's magnetic field lines are the slides, directing them all towards the polar regions. These particles are traveling at incredibly high speeds, full of energy they picked up from the sun. As these energetic particles zoom down into our atmosphere, they start crashing into the atoms and molecules of gas that make up the air we breathe, mostly oxygen and nitrogen. When one of these high-speed solar particles hits an atom of, say, oxygen, it transfers some of its energy to that atom. This excites the oxygen atom, kind of like giving it a jolt of caffeine. But the atom can't stay in this excited state for long. To calm down and return to its normal state, it has to release that extra energy. It does this by giving off a tiny particle of light, called a photon. Now imagine this happening not just with one atom, but with billions and billions of them at the same time. All those tiny flashes of light, or photons, combine to create the giant waving curtains of the aurora that we see from the ground. The different colors of the aurora depend on which type of gas atom is being hit and how high up in the atmosphere the collision happens. For example, when solar particles hit oxygen atoms high up in the atmosphere, above 150 miles, they glow red. When they hit oxygen at lower altitudes, around 60 to 150 miles, they create the most common color we see, a brilliant green. Nitrogen atoms also get in on the fun. When nitrogen molecules are struck by solar particles, they can create beautiful blue or purplish-red hues, often seen along the lower edges of the auroral curtains. So when you look up at the northern lights, you're essentially watching a live painting created by the sun. The sun provides the energetic particles, the paintbrushes. Earth's magnetic field directs them, the artist's hand. And our atmosphere provides the different gases, the canvas and the paint colors. It's a breathtaking collaboration between our planet and its star, a light show powered by the cosmos itself. This is the question on everyone's mind. Will I be able to see it from my house? Thanks to the strength of this particular solar storm, the answer might be yes for a surprisingly large number of people in the United States. Normally, you have to be in places like Alaska to see the aurora reliably. But this weekend, the light show is going on tour. Forecasters from the Space Weather Prediction Center have released a map showing that auroras might be visible, weather permitting, across a huge swath of the northern tier of the country. The states with the best chance of seeing the aurora, provided you have clear, dark skies, include those along the Canadian border. I'm talking about Maine, New Hampshire, Vermont, New York, Michigan, Wisconsin, Minnesota, and North Dakota. Of course, Washington, Idaho, and Montana are also in prime positions to witness the celestial display. These states are often on the edge of visibility during weaker storms. But for a G3 or G4 event like this one, they could get a truly spectacular view, with lights potentially dancing directly overhead instead of just faintly on the horizon. But the excitement doesn't stop there. The auroral oval is expected to dip even farther south. This means that several other states have a real shot at seeing the lights, especially if they look towards the northern horizon. This list includes Massachusetts, Pennsylvania, Ohio, Indiana, Illinois, and Iowa. Even states like Oregon and Nebraska are on the list of possibilities. Seeing the aurora from these locations is exceptionally rare, making this weekend's event a must-watch for any skygazers in the region. It's a chance to see something truly unique without having to travel hundreds or even thousands of miles. So if you live in any of these 18 states, you have a lottery ticket for one of nature's greatest shows. It's important to remember that this is a forecast, and space weather can be as unpredictable as Earth weather. The intensity of the storm can change, but the potential is definitely there. The key will be to get away from city lights and hope for clear skies. This is a chance for communities across a huge part of the country to share in a moment of cosmic wonder, all looking up at the same beautiful sky painted by the sun. When people hear the word solar storm, it can sometimes sound a little scary. We often hear about how these storms can affect our technology, and it's true that very powerful storms can cause some disruptions. The same energetic particles and magnetic fluctuations that create beautiful auroras can also interact with our technological systems. For example, strong geomagnetic storms can induce extra electrical currents in power grids, potentially causing problems for utility companies. They can also interfere with the signals from our GPS satellites, which might make your car's navigation system a little less accurate for a short time. High-frequency radio communications, the kind used by airlines to talk to planes on long-haul routes over the poles, can also be temporarily blacked out during a storm. Satellites in orbit can also be affected. The storm can heat up our outer atmosphere, causing it to expand. This expanded atmosphere creates more drag on satellites in low Earth orbit, which can cause them to slow down and lose altitude if not corrected. Astronauts on the International Space Station are also well aware of these events. But don't worry, the station is well shielded, and they can take extra precautions if a storm is particularly strong. However, it is very important to understand that for a storm of this weekend's predicted magnitude, the effects on our daily lives are expected to be minimal, if any. The people who run our power grids and satellite systems are experts who watch space weather forecasts very closely. They have procedures in place to protect their equipment and ensure that everything continues to run smoothly. So, while your GPS might be a tiny bit less precise for a few hours, your lights will stay on, your phone will work, and the internet will keep running. There is absolutely no need to worry about your personal safety or the safety of your electronics at home. Think of it this way. A solar storm is like a big ocean wave hitting the coast. If you're a ship captain or a lifeguard, you need to pay close attention and take precautions. But for most of us standing on the beach, it's simply a spectacular and beautiful event to watch. This storm is a gentle giant. It has enough power to paint our skies with incredible light, but not enough to cause widespread problems for our modern lives. So you can relax and focus on the positive side of this event, the incredible, awe-inspiring light show it's bringing to our skies. You're excited, you're in the right state, and you're ready to see the northern lights. So, how do you give yourself the best possible chance? First things first, timing is everything. The best time to look for the aurora is generally around local midnight, between the hours of 10 p.m. and 2 a.m. This is when the part of Earth you're on is typically facing away from the sun and is most directly in the path of the incoming solar particles. While the aurora can sometimes be visible earlier or later, this 4-hour window is your prime time for viewing, so plan for a late night. Next, location, location, location. The number one enemy of aurora viewing is light pollution. The faint, beautiful glow of the aurora can be easily washed out by the bright lights of a city. To see the show, you need to get as far away from urban areas as you can. Find a spot with a clear, dark sky, like a state park, a rural field, or a lakeside beach. It's also crucial to have an unobstructed view of the northern horizon. Since you'll be seeing the aurora from farther south, the lights will likely appear low in the sky to the north. Find a spot on a hill or by a lake where no tall buildings or trees are blocking your northern view. Patience is a virtue, especially for aurora hunters. Your eyes need time to adjust to the darkness. It can take up to 20 or 30 minutes for your eyes to become fully dark adapted, which will allow you to see faint colors and structures in the sky. So, when you get to your viewing spot, turn off all your lights, including your phone screen, and just wait. The aurora can also come and go in waves. It might be faint for a while and then suddenly burst into bright, fast-moving curtains of light. Don't just peek outside for 5 minutes and give up. Plan to stay for at least an hour or two. Finally, a few more pro tips. Check the weather forecast. You can't see the aurora through thick clouds. Also, check the phase of the moon. This weekend, on August 8th, 2025, we are lucky because the moon will be in its waxing crescent phase, meaning it will set early in the evening and won't be very bright. This creates perfect, dark conditions for aurora watching. Dress warmly, even if it's an August night, as you'll be standing still for a long time. Bring a chair, a blanket, some hot chocolate, and a friend. Seeing the aurora is an amazing experience, and it's even better when you can share it. As we stand under the vast night sky, waiting for a celestial show to begin, it's a wonderful moment to reflect. This event is more than just pretty lights. It's a direct connection to the powerful, dynamic universe we live in. The energy that will create these auroras began its journey 93 million miles away, on the surface of our sun. It traveled across the solar system and is now interacting with our planet's atmosphere to create a work of art just for us. It's a profound reminder that we are not isolated but are part of a grand cosmic dance, intricately linked to our star and the space around us. Think about all the people across the country who will be doing the exact same thing you are this weekend. From a field in rural Ohio to a lakeshore in Minnesota, from a hilltop in Vermont to a backyard in Washington, people will be gathered together, looking up in shared anticipation. In a world that can sometimes feel divided, events like this have a beautiful way of uniting us. We are all citizens of planet Earth, looking up at the same sky, marveling at the same natural wonder. It fosters a sense of community that transcends geography and brings us together in our shared curiosity and awe. This is also a fantastic opportunity to spark curiosity and a love for science, especially in kids. When you can see science happening in such a spectacular way, it's no longer just a subject in a textbook. It's real, it's beautiful, and it's exciting. Explaining to a child that the colors they are seeing are caused by particles from the sun hitting atoms in our air can ignite a lifelong passion for understanding the world around them. It's moments like these that create the next generation of scientists, engineers, and explorers. So, as you head out this weekend, I hope you see a magnificent show. But even if the clouds roll in or the lights are too faint to see, remember the journey. Remember that you took a moment to step outside, to look up, and to connect with the cosmos. You participated in a collective moment of wonder shared by millions. The universe is constantly putting on incredible shows for us, and sometimes, if we're lucky, we get a front row seat. This weekend is one of those times. Here's to clear skies and a beautiful display of cosmic art.